Hey, digital assistant, start my coffee pot, if you wouldn't mind. Thanks. Now, while we're waiting for her to respond, let's talk about speech recognition. Now, speech recognition is becoming more and more critical in IoT designs these days. And for most of us designing systems that rely on voice commands, that presents a big problem. Yep, we may have to send that audio back to a server somewhere to be analyzed. Hey, did she get my coffee request yet? My internet connection must be acting up today. Anyway, if you're designing a voice control system for something like a car, you need voice processing to be done locally. I mean, when you ask for the pod bay doors to be opened, you want the pod bay doors open right now, not 20 minutes later after the audio data makes it back to Earth to be processed while you breathe your last remaining bit of... Yeah, okay, maybe I'm getting carried away. Hi, I'm Amelia Dalton, host of Chalk Talk. My guest today is Gerard Andrews from Cadence Design Systems, and we're going to talk about processing voice commands and doing speech recognition locally using the Tensilica HiFi DSP. So let's get started. And where's that coffee? Anyway. And before we get started, don't forget to click that link. There you can find more information about the Tensilica HiFi DSP. Hello, Gerard. Thank you so much for joining me.
Thank you for having me.
So I feel like voice control is everywhere these days. Even my kids are talking to Alexa. But is this just me?
I think it is everywhere. If you'll look here at the slide, you'll see that in September, Amazon announced 8 new devices that contain their Alexa voice control service. And some of these might be familiar to you if you have Amazon Echo devices in your home, like a updated Echo Dot or updated Echo Show. And some of these things are actually quite new. There's an Echo subwoofer, an updated Echo Ring security camera, and 2 of the things I found even more interesting. There's an Echo Auto. So if you can't live without Alexa and you need to bring her in the car with you, there's a product to bring Alexa in the car with you. And my favorite, a new $60 voice controlled microwave, which is one of my favorite products. It's something I didn't know I needed until they released it. But I think when you look at the totality of these 8 new devices, you get the idea that Amazon and others that are offering voice control services want to be wherever you are, in the home, in the living room, in the kitchen, in the car, to offer their voice service. And I think that's a real statement and endorsement of how well consumers are adopting voice control devices.
So we're definitely seeing voice control a lot in the home. But how is the automotive market reacting?
That's a very good question. And I think that the automotive manufacturers are seeing the success of the Alexa devices, the Siri devices, the Google Home devices, and are really putting their stake in the ground to improve the voice service in the automobile. In this slide here, we're highlighting a new partnership between Mercedes-Benz and SoundHound, where they are adding a voice control AI infotainment platform for the car that, if it works as advertised, will provide natural language type interaction for the vehicle. Now, the car itself is a little bit different use case than in the home because the cloud voice recognition service is not always guaranteed to be there. So there's a real desire to be able to do a lot of this high quality voice UI experience when there's no cloud availability, which means you need to do it locally.
So what are some of the challenges in that space?
When you're doing things locally, you don't have the infinite compute resources of the internet, but we have seen a trend of embracing doing speech recognition at the edge. And there are some advantages you get out of that. One, first and foremost, is privacy concerns. So if you are doing a command in a smart home that says close garage door, then you don't have to worry about your service provider knowing when you opened or closed the garage door. Yeah, I think it's a reasonable expectation that you should be able to close that without having to send that to the cloud. The other things about speech recognition at the edge is the low latency performance, which means that when you are talking to the machine, the response you get back from the machine is much quicker and much more interactive if you are having a natural language type voice interaction. That's a second benefit. And the third one is if you don't have the internet available to you, you would still like to have some ability to voice control. If you are setting your thermostat up or down, or inside of the car, if you were saying rear window up or rear window down, you wouldn't want to lose that functionality because you lost a cloud connection. And so with all these advantages of speech recognition at the edge, there has to be some technology that enables that. In this case, the past few years, I've seen an explosion in neural net algorithmic techniques that have made it possible to do this type of computation locally. And you marry these advanced algorithmic techniques with high performance DSP cores like we offer at Tensilica, and that really are some of the key enabling factors that allow speech recognition to happen at the edge.
Okay, so I mentioned before about my kids chatting with Alexa, but what exactly is going on when they do that?
Great question. I think that the processing that goes on inside of Alexa type device or Google or Apple device or many devices from other manufacturers, they really fall into two categories. And the first category is the voice pre-processing. And that is where you're doing a lot of advanced DSP calculations to try to isolate the speaker's voice from the environment. And so there are some techniques like beam forming and noise reduction and acoustic echo cancellation, all trying to isolate that voice before you pass it off to the speech recognition engine. And the second part of that equation is the speech recognition itself. As we talked about before, most of that today is happening in the cloud, but we do see some trends where that could actually happen, locally as well. But whether it's in the cloud or local, the functionality is the same. There is some feature extraction, and then there are some neural network processing layers and language decoding that help turn the audio signal into text.
Okay, so what about Cadence's new products for voice UI?
That's why I'm here. So I'll talk about the HiFi DSP, which we recently announced October 31st, and it's very much targeting these voice-controlled applications. And we have a lot of interest from customers making chips targeting voice UI. The previous generation of DSP in this space was the HiFi 4, and we worked closely with a large number of customers who had adopted HiFi 4 for smart home and automotive applications. And we're building on those learning experiences with the HiFi 5 DSP. So we've talked a lot about smart home, and that's enabling the voice control through the home. We talked about the automotive case, where the automotive manufacturers are really following the smart home and improving the voice UI experience there. A new use case that we hadn't mentioned so far in the conversation is about headphone type of inhearable applications where people want to use the headphones to do some local voice commands, turn music up, turn the music down, or actually talk to their voice assistant through the headphones. And so that is a really hot emerging application for us. And finally, there's the HiFi 5 will have a lot of features to do voice, but it will be a good DSP. And we have noticed a trend that in automobiles, there's a big increase on the horizon for the amount of listening experiences and the quality of listening experience in the car. And we do expect HiFi 5 to have some adoption there.
So what kind of advantages can I get with the HiFi 5?
Well, I mentioned before that HiFi 5 was designed with a lot of input that we got in feedback on the HiFi 4 DSP. And so just comparing to that previous generation of DSP, HiFi 5 offers 4x the neural net processing capability of the HiFi 4 DSP and up to 2x of the audio DSP processing relative to the HiFi 4 DSP. The other big benefit of HiFi 5 is that it's a highly configurable core, meaning that our licensees can set it up to do classic DSP only, classic DSP plus neural net processing, or include only the instructions that they need for their application. And then finally, when you release a core, You need some software that enables your customers to take advantage of those new features in that core. And we have a new neural net processing library available with HiFi 5, as well as software compatibility with the HiFi product line, which brings in a lot of existing software.
So do you have any more details on how this new architecture compares with the older generation?
Sure. So I have a chart here, and basically you can see that HiFi 5 relative to HiFi 4, it doubles the load store bandwidth. So it was a dual 64-bit machine, and now it's a dual 128-bit machine. Why we decided to increase that load store capability is, for the most part, we've doubled the multiply accumulate capability. So if you look at the fixed point max on this machine, there were 4 at 32 by 32 bit, and now there are 8. And so that kind of goes hand in hand. If you double the amount of max, you need to double the bandwidth to feed them. And so that's what we did there. And in the odd color blue dead in the middle of that chart, we added a new set of multiply accumulates that were previously not available in HiFi 4. And these are our fixed point neural net max. And we have 16 by 16 as a very popular size of that multiply accumulate, which can do 16 per cycle. And then the smaller weights, 16 by 8, 16 by 4, 16 by 2, and 8 by 8, we could do 32 max per cycle. If you recall before, we had mentioned that there's a 4x improvement of HiFi 5 relative to HiFi 4 for neural net processing. That basically is derived from the fact that we're going from an 8 Mac machine to a 32 Mac machine. And we had also mentioned before that there's a 2x improvement on classic audio DSP processing. And that really ties into the fact that we are doubling the audio Mac capability from 4 Macs to 8.
So you mentioned a lot of architectural details, but can we look in particular about what you've got for neural network processing?
I think the key thing for neural net processing was moving from the 8 Mac machine to a 32 Mac per cycle machine, because, at the heart of all this neural net processing, there's just a lot of multiply accumulates. So that was the big driver there. Other things, we've added special instructions to accelerate the neural net activation functions. So TANH, sigmoid, softmax, and RailU, those are all accelerated in the HiFi 5 architecture. That was previously unavailable in the previous architecture. We noticed a trend in the literature to try to really move down the weights that are associated with neural net processing. So we added support for smaller weights. So we can handle 8 bits, 4 bits, 2 bits, and 1 bits in this machine. Even though a lot of the algorithms might not be taking advantage of that today, we noticed that the trends and the innovation happening in neural net processing all are pointing to smaller weights. So while we were designing the core, let's go all the way down to 1 bit and, let's see if somebody is able to take advantage of it. We added other things like instructions for efficient parsing of sparse matrices, because there is a lot of interest in the research. One of the key things we wanted to do was look what was happening in the innovation, and as much as we could into the future, open those up for a possibility for efficiently running on the HiFi 5.
Cool. Can we look under the hood at this thing?
Great. Yeah, I'll explain. This is a graphical representation of the HiFi 5 DSP architecture. We use this type of format to explain the HiFi architecture, and it should be familiar if anyone in the audience has seen one of these HiFi 4 or HiFi 3 DSPs in the past. But basically, there's a separate bus from the instruction memory that's 128 bits wide that is fetched and decoded. And this is a VLIW machine, which means that up to 5 instructions can be issued per cycle. And the slot 0 and slot 1 of this machine usually perform the load store operations as well as the scalar operations. And then in this machine, the slot 3 and slot 4 does the heavy DSP lifting. So your multiply accumulates, your vector floating point unit, your half precision vector floating point unit. All of these things are done in slot 3 and slot 4. And then we do have a 5th slot where a small number of vector ops are run. The other main point to point out here is there's a data memory interface that's separate from the instruction interface, and it is a dual 128-bit machine. And this is where the DSP engine is fed with all the data that must be calculated in the audio processing or the neural net processing. And one other color code is not on the slide, but the things in the white boxes are optional instructions that are included when you configure the core. So if you set your core up, if you know you won't need those instructions, you don't have to include them, but we made those optional. And so you can see how when you select the different option, where they might be included and run in the core.
So you said earlier that the core is configurable. What kind of options are there?
Great question. The first option, and I think the one that'll be most used given the target applications that we're going for, is the neural net config option. And we had mentioned these features before, but just to recap, all of the lower precision multiply accumulate instructions that we added to this machine, the 16 by 16, 16 by 8, 16 by 4, 16 by 2, 8 by 8, plus the neural net specific instructions like TAN 8 and ReLU are all included when you select the neural net config option when you build your core. If you are using it for classic DSP applications like audio decoder chip or something, and you did need the neural net processing, you would not have to include the area or the power associated with that neural net option. The next option that we have is a vector floating point unit. And this vector floating point unit is quite powerful. It's capable of doing 8 max per cycle of single precision floating point. This is 2 times the performance that we had on the previous generation on the HiFi 4 DSP. The other option is a half precision vector floating point unit. And so this is often referred to as FP16. And this is a new option that can do 16 max per cycle. And it could be really useful if you're bringing over neural net processing models that were previously designed to run on different cores like a GPU, which often use half precision floating point. So this really gives some flexibility to customers who know what type of neural net models they might run, and they want to have that option. If you know for sure you're not going to use half precision floating point, you don't have to include the area. And the final option is not so much a instruction set architecture option. It is a more base core option that we added. If you use our integrated DMA unit in a particular core, previously it was only available as a 128-bit interface, but because the neural net processing algorithms are so data movement intense, we added a 256-bit option so you can bring data across the AXI bus into the processor at double the speed of what was previously offered on the HiFi 4.
We all know that a piece of hardware is useless without the software. So what have you guys got for us there?
Absolutely. So for the first time, we've added a neural net library to the HiFi DSP product line. And so there are a number of networking processing layers that we will hand code, hand optimize so that our customers can spend time building their own models and not hand optimizing on our architecture. So we will have LSTMs and GRUs, which are 2 common forms of RNNs very heavily used in speech recognition and audio processing. We'll also include CNN-based neural net processing layers, as well as kernels that are into activation and pooling, so sigmoid and TANH and ReLU. So these will be very highly optimized, very flexible, and are really designed to help our customers accelerate their time to market of moving their neural net models onto our platform in a highly optimized manner. And building on this next slide here, we mentioned the neural net library. We've always provided a DSP library with our HiFi DSPs, and HiFi 5 is no different. These are optimized math libraries where you see common DSP functions like FFT, FIR filters, IIR filters, and trigonometric functions. So that will be a part of the product offering. Also at Cadence, we have a very comprehensive set of audio and speech codecs that we offer to our licensees. Think about AAC, MP3, MPEG-H, and Dolby codecs, all these audio compression standards. So because the HiFi 5 is software compatible with the other members of the HiFi architecture, a simple software recompile will make all of this audio software ecosystem available. And then finally, last but not least, we have a very large ecosystem of software partners, more than 125 different companies that offer audio and speech processing on HiFi. Their software will be immediately available on HiFi 5, and they range from virtual reality software to services companies that specialize in programming for HiFi 5.
So, have you had any customers use this, and what has their response been?
We are very pleased to say that before we even launched, HiFi 5 has its first licensee. It is a Austin-based ultra-low power microcontroller company called Ambic Micro. They have a unique patented sub-threshold technique, which allows them to claim an order of magnitude lower power consumption than their competitors. And they are very interested in bringing neural net processing to very battery energy sensitive devices, and have announced their plan to use the HiFi 5 with their sub-threshold technology to kind of enable this trend. We had mentioned earlier about having earpieces that can hear you and listen and respond to you, and I think Ambic Micro is positioned to play a big role in that space.
Okay, cool. So, Gerard, this has been a lot to take in today, so could you summarize your main points for me?
On a performance level, HiFi 5 is a 4x improvement on this neural net processing capability relative to the market-leading HiFi 4 DSP. There's a 2x improvement on the audio DSP processing relative to HiFi 4, so a big jump up in performance. As you know, these systems have multiple microphones and they want to work from farther away and they want to cancel more and more noise, so that means they need more MIPS, and that's what's provided in HiFi 5. The second big point is it's highly configurable. You can include a floating point or half precision floating point or the neural net option, or choose the size of the AXI IDMA interface. A lot of flexibility there. And then finally, we're not just offering the core, we have a lot of software available. One new piece of software is the neural net processing library. But because of the software compatibility with the HiFi ecosystem, there's a lot of software directly from Cadence and our 125 plus ecosystem partners.
Cool. Well, I think that's all I have time for today. Thank you so much for joining me, Gerard. It was a pleasure speaking with you.
Thanks for visiting us in Austin, Texas.
And before we go, you didn't forget to click that link, did you? There you can find even more information about Cadence Design Systems' Tensilica HiFi 5 DSP. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talk section of EE Journal. Can't miss it, right across the top. Or head on over to YouTube. Keyword EE Journal.